All right, I've set up another example. It's actually the same graph we just looked at, but I want us to find the area below the graph. And as we're doing it, I want you to think of what it might represent. We'll certainly get there. Okay, so to find the area, no big deal. Just turn it into a shape here. Okay, it's clearly a triangle. The area of a triangle, we say base times height divided by 2. So the base here would be 14 centimeters. I'm going to put that into meters. The height is 5 newtons. Okay. And that's going to give me 0.7. Okay. The units here, meters times newtons, I'll call that Newton meters. What does that represent? Maybe it makes sense to think of it this way. It's a force times a displacement. What does that give you? Okay, I'm hoping you're yelling at your screen. It gives you work. Okay, so this is the work done to stretch the spring 14 centimeters. Okay. Now, maybe we can take this further, because remember, work is energy. So you could actually write this as 0.7 joules. All right, so by doing this much work to the spring, that energy doesn't disappear, because you know if you let go of the spring, it's going to start oscillating, which we talk about a lot as we get into the next unit next week. All right, but certainly when you let go of a spring that you've stretched, that energy doesn't go anywhere, it just transforms. Okay, so it's the work done to stretch the spring, or you can think of it as the energy stored in the spring. And we're certainly going to do examples. This is the energy unit with the spring transforming energy between kinetic and potential. The energy stored in a spring is a type of potential energy. You call that elastic potential energy. Okay, I also want to show you one more thing. The elastic potential energy was the area under this graph, which was base times height divided by 2. Or you can think of that as the force times the displacement divided by 2. Okay, but you don't actually use that formula so often, because remember, Hooke's law is just this, F equals kx. Okay, so I can change that F to kx, and we get this formula, which we will use. Okay, kx times x is kx squared divided by 2. Typically you write it like this. All right, which is a really, really similar format to the kinetic energy formula. There's a good reason for that. Keep doing math and physics classes and it'll start making a lot of sense. Okay.